This is SpaceTime Series 26, Episode 83. Coming up on SpaceTime, liftoff, the Euclid Space Telescope heads for L2. Ancient volcanic activity discovered on the far side of the Moon. And NASA's Mars Ingenuity helicopter has suffered another communications blackout. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The European Space Agency's Euclid Space Telescope is now on its way to orbit in the Lagrangian L2 position on the dark side of the Earth following a successful launch aboard a SpaceX Falcon 9 rocket from Cape Canaveral in Florida.
5, 4, 3, 2, 1. Ignition. Liftoff. Stage 1 propulsion is nominal. Vehicle is pitching downrange.
Falcon 9 has successfully lifted off from pad 40 and throttled down to prepare for max Q, which is coming up at T plus 1 minute.
Power and telemetry nominal.
1 minute and about 12 seconds.
Maximum dynamic pressure.
And great news. We have passed through max Q. Next up, we have a few events happening back-to-back. That will be MECO, stage separation, and SES-1. MECO is main engine cutoff, and that's where we'll shut down all 9 of the M1D engines to slow the vehicle down in preparation for its next event, which is
MVAC chill has started.
Stage separation. And that's where the first stage separates from the second stage. Right after stage separation, the first stage will begin its journey back to Earth for landing on our drone ship, a shortfall of gravitas. And during that time, stage 2 will continue on its journey with that third event, SES-1 or second stage engine start 1. And that is where the single Merlin vacuum engine will light up and propel the second stage along with ESA's Euclid spacecraft to orbit. In addition to these 3 major events, the fairing halves will separate less than a minute after SES-1.
Main engine cutoff. Stage separation confirmed. MVAC ignition.
MECO stage separation, and the MVAC engine has ignited.
Both vehicles are following nominal trajectories.
Grid fins on the first stage are deploying, and in about 15 seconds or so, we should have fairing separation.
Fairing separation confirmed.
The fairing halves have deployed. Both fairing halves are brand new and are now making their way back down to Earth and will be recovered by our recovery vessel Doug today. White puffs on that first stage, that is nitrogen gas puffs for attitude control.
Stage 1 FTS has safed.
The engines have reignited on the first stage. This is the entry burn with 3 of 9 M1D engines reignited. The vehicle will be landing for its second time today. And just before the landing burn begins, we will also have SECO 1 on the second stage. That is second engine cutoff 1. That's where we'll shut down that MVAC engine on the second stage. This is the first of 2 burns for this mission, and that is coming up here in just a few seconds, followed by the landing burn about 20 seconds after that. MVAC engine has shut down, and the landing burn has begun on the first stage vehicle.
Expected loss of signal. Cape. Nominal orbit insertion.
Falcon 9 touching down on a shortfall of gravitas. This landing marks the second successful landing for this particular booster and marks our 204th overall successful recovery of an orbital class rocket, including both Falcon 9 and Falcon Heavy first stages.
Following launch and separation from the rocket, ESA's European Space Operations Centre in Darmstadt, Germany, confirmed acquisition of signal from Euclid by way of the New Norcia ground station in Western Australia. Once it's in position 1.5 million kilometres from the Earth, it'll join the James Webb Space Telescope, which is orbiting nearby, in studying the infrared universe. But just getting Euclid to space has been a monumental task, as Andreas Rudolph, ESA's Flight Operations Director for Euclid, explains.
The telescope is sitting upright under the fairing of the rocket before it's lifting off. So any particles that fall or may fall from the fairing into the telescope can immediately lead to degradation of the sensitivity of the instrument. And basically what you do in order to not get particulate contamination is that you have a very, very clean and new fairing. So this fairing for Euclid has very special requirements. It's a new fairing. It's not one which has been reused from a previous Falcon 9 flight. It also is very clean in order to make sure that we don't get any particulates into the telescope that may degrade it once in orbit. We make sure the telescope is very, very stable and very well calibrated, because what we're looking for is really very difficult to measure, because otherwise we would have measured it already from ground. So I think in a nutshell, those are the challenges we have here for Euclid. So Euclid is a mission that is a cosmological mission, is looking back 10 billion years into the past and the evolution of our universe. So in order to do this, you need a very, very sensitive instrument. So once we are in orbit, one of the things that Euclid is never allowed to do is to look with its telescope and its very, very sensitive instruments into the sun. To make sure that doesn't happen, we have two things. First of all, we have a so-called sun shield, which is protecting us from the sun as long as the spacecraft is pointed correctly. And the second thing is we have automatic protection mechanisms, which make sure that whenever the sun is approaching the telescope line of sight, we immediately switch into a fallback mode to make sure that it doesn't happen.
While the Webb Space Telescope will find specific targets and then zoom in on them with unparalleled clarity, Euclid will undertake a large-scale survey and mapping program. It's specifically focusing on studying the dark forces of the universe, dark matter and dark energy, two of the biggest mysteries in science, and neither of which are well understood. Although the name dark matter seems to suggest that the matter is in fact dark, it's probably better called missing matter, the darkness referring to our lack of knowledge. When scientists observe large objects on a galactic scale, they notice the behavior of these objects doesn't fit the standard model for gravity. For example, there seems to be some additional amount of mass which provides extra gravity needed to hold galaxies together and stop them flinging apart as they rotate. But even more interestingly, stars on the outer edges of galaxies appear to orbit the galactic center at the same speed as those closer in towards the center. And that just doesn't happen in real life. In fact, if you look at our own solar system, you can see that our planets don't do this. They match our expectations. It's as if there's a huge amount of additional mass, over 80% more than what we can see, that's holding everything together. And that's what scientists are calling dark matter. And although its actions are observable, it itself is invisible. We have no idea what it is. And it doesn't end there. Along with the observable evidence of dark matter comes dark energy, the accelerating expansion of the universe. When we look at deep space, almost everything in the distance seems to be moving away from everything else. And the further away you look, the faster things seem to be moving. But that rate of expansion isn't even. The movement seems to be accelerating. On a galactic scale, every object seems to exhibit a redshift, similar to the Doppler effect in pitch you hear when, say, an ambulance or fire engine passes you with its sirens on. Basically, the sound waves moving towards you as the vehicle approaches are compressed or blue-shifted, while the sound waves moving away from you as the vehicle disappears in the distance are stretched or red-shifted. And it's the same thing with light waves. The further away the object is, the greater the redshift. For very distant objects, that redshift is stretched beyond the visible light into the infrared part of the spectrum, which is where telescopes like Webb and Euclid operate. Understanding dark energy will help scientists answer one of the ultimate questions of the universe. What is our ultimate fate? Will the expansion of the universe eventually slow down and stop, resulting in a sort of steady state where things stay pretty much the way they appear now? Or will gravity then take over and gradually cause everything to start to reverse and contract, eventually crashing back together in a big crunch, which could then trigger another big bang, then another big crunch, and so on? Is that how the universe works over eternity? Or will the universe continue to expand forever until eventually only the stars in our own galaxy will be visible, that is, until they burn out and begin to wink off one after another, eventually leaving the universe cold and dark, what astronomers call the Big Freeze? Or will dark energy cause that rate of expansion to continue to accelerate until it becomes so strong that galaxies are flung apart, star systems are torn asunder? Maybe dark energy becomes so strong that planets are ripped apart and ultimately even atoms are split into the constituent quarks and electrons, the so-called Big Rip. Euclid's mission is to better understand these phenomena. Accurate, large-scale observations are needed, not only to map the 3 dimensions of space, but the 4 dimensions of space-time. Euclid's going to create a massive archive of data of everything it can see, billions of galaxies and quasars, out to some 10 billion light years over time, with the idea of seeing the effect of dark matter and dark energy at a level of detail unparalleled so far. This high-precision chart of the shape, position and movement of galaxies will reveal how matter is distributed across immense distances in the cosmic web and how the expansion of the universe has evolved over cosmic history, enabling astronomers to finally infer the properties of dark energy and dark matter. This will in turn help theorists improve our understanding of the role of gravity, the oldest and least understood of the forces, and it will pin down the nature of these enigmatic entities. Named after the great Greek mathematician Euclid, the 2,160-kilogram spacecraft will achieve its ambitious science goal using a 1.2-metre reflecting telescope that has two innovative scientific instruments. The VIS, which takes very sharp images of galaxies over a large fraction of the sky, and the NISP, which can analyse galaxies' infrared light by wavelength to accurately establish their distance. The data will then be fed to some 2,000 scientists from 300 institutes around the world. Among them is Satoshi Miyazaki, the director of Japan's Subaru telescope.
Euclid is a European space mission which has a 1.2-meter telescope combined with visible and infrared imager and spectrograph. We have a division roles between Euclid and the ground-based telescope. Euclid takes a very sharp image, very deep, toward very faint objects. However, they don't take a color information. In that sense, we provide color information. The Subaru's features a wide field camera, which we call Hypers Prime Cam. That is a very unique camera in terms of light collecting power, because it's 8.2-meter telescope, and very wide field, like a 1.5 degrees across. Combined with the large collecting power and wide field imager, we can survey very quickly over the very wide field. We have a very high sensitivity in red. We are very good at taking the red sky in the longer wavelengths. The CFST megacam features high sensitivity in the blue band, so the combination of the high blue and high red makes perfect sense. That's the collaboration makes perfect sense.
Over the next 4 weeks, Euclid will travel towards the Earth-Sun Lagrange L2 position, an equilibrium point in the Earth-Sun system located about 4 times further away from the Earth and the Moon. Euclid will be manoeuvred into orbit around this point, and mission controllers will start the activities to verify all the functions of the spacecraft, check out the telescope itself to make sure it survived the launch, and finally turn on the scientific instruments. Scientists and engineers will then be engaged in an intense 2-month-long phase of testing and calibrating Euclid's instruments and preparing the spacecraft for routine operations. Over the next 6 years, Euclid will survey a full third of the sky with unprecedented accuracy, providing a degree of sensitivity never before seen. This report from ESA TV.
Euclid's 6-year mission will explore the so-called dark side of the universe. Astronomers have discovered that 95% of the cosmos is made up of unknown forms of matter and energy called dark matter and dark energy. Euclid will map approximately 1.5 to 2 billion galaxies to look for the subtle effects that dark matter and dark energy have on the structure and expansion of the cosmos. Once the analysis is complete, vital clues about the behaviour and characteristics of dark matter and dark energy will be revealed.
This is SpaceTime. Still to come, ancient volcanic activity discovered on the far side of the Moon, and NASA's Mars Ingenuity helicopter finally phones home after losing contact for 2 months. All that and more still to come on SpaceTime. Astronomers have discovered a large granite formation below the lunar surface far side. The massive slab, reported in the journal Nature, was likely formed by cooling of molten lava that fed a volcano or chain of volcanoes that must have erupted early in the Moon's history, possibly as far back as 3.5 billion years ago. Scientists made the discovery while examining microwave frequency data to measure heat below the surface of a suspected volcanic feature on the Moon known as Compton-Belkovich. The authors used this data to determine that the heat being generated below the surface was coming from a concentration of radioactive elements which can only exist on the Moon as granite. Granites are the igneous rock remnants of the plumbing systems below extinct volcanoes. Granite formations left in the wake of lava that's cooled without erupting are known as batholiths. The study's lead author, Matthew Siegler from the Planetary Science Institute, says any big body of granite found on Earth used to feed a big bunch of volcanoes, much like the large system feeding the Cascade volcanoes in the Pacific Northwest today. Ziegler says batholiths are much bigger than the volcanoes they feed on the surface. For example, the Sierra Nevada mountains in California are a batholith left over from a volcanic chain in the western United States that existed long ago. The Lunar batholith is located in a region of the Moon previously identified as a volcanic complex. But researchers are surprised at its size, with an estimated diameter of some 50 kilometres. Granite's pretty common on Earth, and its formation is generally driven by water and plate tectonics, which aid in the creation of large melt bodies below the Earth's surface. However, granites are extremely rare on the Moon because it lacks these processes. Ziegler says finding this granite body helps explain how the early lunar crust must have formed. He says if you don't have water in the process, it takes extreme conditions to make granite. So, here's this system with no water and no plate tectonics, but you have granite. And that begs the question, was there once lots of water on the Moon, at least at this one spot? Or is it just that this one spot was unusually, especially hot? This is SpaceTime. Still to come, NASA's Mars Ingenuity helicopter phones home after losing contact for 2 months, and later in the science report, researchers warn of the growing threat of low crop yields due to worsening climate change. All that and more still to come on SpaceTime. NASA's Mars Ingenuity helicopter is finally phoned home after suffering another communications blackout, this one lasting for a record 63 days of radio silence. But unlike the last blackout, this one was expected. Mission managers thought communications might drop out because of a hill lying between the rotorcopter's landing location and the position of its Perseverance rover base station, blocking communications between the two. You see, the car-sized 6-wheeled rover provides a radio relay between the helicopter and NASA's mission controllers at the Jet Propulsion Laboratory in Pasadena, California. So scientists had to wait until the Perseverance rover crested the hill and was back in line of sight of the helicopter before communications could be re-established. Ingenuity Flight 52 was a 363-metre, 139-second-long journey designed to reposition the tissue box-sized helicopter and take images of the surrounding terrain for the rover science team. Perseverance and Ingenuity are currently sitting on top of the Jezero Crater River Delta Fan, a rugged terrain which makes communications difficult and radio dropouts more likely. Now, the goal at this moment is to simply keep Ingenuity ahead of Perseverance, which mission managers say means occasionally pushing it beyond its communications limits. The good news is the data downloaded from Ingenuity indicate that all systems are nominal, and the 1.8 kilogram chopper will be ready for Flight 53, which will head westwards towards a rocky outcrop which scientists want Perseverance to explore. Just over 2 months ago, mission managers unexpectedly lost contact with Ingenuity for 6 days. That was caused by a combination of challenging topography between the helicopter and the rover and also low battery power aboard Ingenuity due to increasing dust levels covering its solar array. A brief 2-day loss of signal happened about a year ago, also due to the chopper's batteries not getting enough charge from the solar array as Jezero Crater moved into the Martian winter. The robotic Ingenuity helicopter arrived on the red planet attached to Perseverance rover's underbelly back in February 2021. Of course, Ingenuity was only ever designed to undertake 5 or 6 demonstration flights, simply to confirm that an aircraft could fly on another planet. But it's now undertaken 52 flights, and it's proven to be a huge help for mission managers, scouting ahead of the rover, looking for the best route, and spotting interesting geological features. Now, speaking of interesting features, the Perseverance rovers captured an image of a strange donut-shaped rock in Jezero crater. The rover photographed the mysterious monolith from a distance of about 100 metres, using its remote microscopic imager, which is part of the SuperCam instrument. Of course, oddly shaped rocks aren't uncommon, either on Earth or Mars. They're often formed over eons as winds sandblast rock faces. Now, this particular rock may have formed after a small rock, or multiple rocks, eroded near its centre, and that left behind a cavity which was later enlarged by the wind. The rover had captured an earlier image of the same rock 2 months ago, but that was from a distance of around 400 metres using the Mastcam Z instrument. This new image shows the strange donut-shaped rock with far greater clarity. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that the growing problem of climate change is increasing the likelihood of major food-producing regions, such as North America and Eastern Europe, simultaneously producing low crop yields. The findings, reported in the journal Nature Communications, are based on new computer modelling and suggest that current climate models underestimate the risk global warming poses to global food security. The authors stress the urgency of rapid emission reductions in order to prevent climate extremes and their complex interactions from becoming increasingly unmanageable. The findings suggest potential high-impact blind spots in current climate risk assessments and highlights the urgent need for more research to support model improvements in climate and agricultural domains. Dutch archaeologists have uncovered a 4,000-year-old religious site, which they've dubbed the Stonehenge of the Netherlands, which includes a burial mound that served as a solar calendar. The 20-metre-wide burial mound, located southeast of Utrecht, contained the remains of 60 people, including men, women and children, and had several passages through which the sun directly shone on the longest and shortest days of the year. The scientists from the University of Groningen also discovered 2 other smaller mounds. It's thought the 3 mounds were used as burial sites for about 800 years. Geoffrey Hinton, the so-called godfather of artificial intelligence, has again urged governments to step in and make sure that AI machines do not control society. Hinton made headlines back in May when he quit his job at Google after a decade of work to speak more freely about the dangers of AI following the release of ChatGPT. The highly respected AI scientist issued his latest warning to the packed audience at the Collision Tech Conference in Toronto. The conference has brought together over 30,000 startup founders, investors and tech experts, all looking to learn how to ride the AI wave. But Hinton's warned for every 99 smart people trying to make AI better, there's only one very smart person trying to figure out how to stop it taking over. And maybe society should want there to be a bit more balance in this area. He says it's important that people understand that this is not science fiction, it's not just fear-mongering. He insists there's a real risk that humanity needs to think about, and people need to figure out in advance how to deal with it. He also pointed to the dangers of fake news being created by ChatGPT-style bots, saying AI-generated content should be marked in a way similar to how central banks watermark money. Telstra, Australia's largest telco, has issued their mid-year assessment of where the company is heading and what its future holds. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
Well, they made a series of announcements. The first one was that they reached 85% of the population with 5G coverage as at June 30, 2023, so the mid-year point, and they're on track to hit 90% coverage plus during 2025. Already 38% of their traffic is carried over its 5G network, and they want 80% by financial year 2025. And they say that more traffic on their 5G network means a better experience. They're going to be shutting down their 3G network as already disclosed in 2024. And actually I asked today about the 3G coverage, that when I find myself on 3G, I have practically zero bandwidth. It's like you're disconnected. It's just for voice. And they've committed to replicating all of that 3G coverage with 4G coverage, which would be a lot better because you can get a decent connection by the time they switch the 3G off. And of course, they're trying to get 5G in as many places as possible. They've also got a thing called Cloud RAN, and this is where you can run part of the phone's network, the radio software inside the cloud. And this is their radio software that I guess determines the frequencies that it's able to broadcast on. And they've got the first commercial call was done last December on a Cloud RAN network running in the cloud, and they've actually got that deployed in 7 sites in Queensland with more to come. So in addition, they're going to be reselling Elon Musk's satellite service for rural and regional areas only, basically in places where they can't service it with other connections. And they'll do voice, and also they'll do voice and broadband. And apparently the voice aspect is a first that hasn't been done before, which is pretty cool. And they also had a second generation of their 5G home broadband Wi-Fi device with a bigger Wi-Fi range than even their NBN smart modem 3 and more than their 5G first generation home broadband modem. And this second generation is also compatible with Telstra Wi-Fi mesh extender so that you can create an even larger Wi-Fi network under the same network name, not with any strange extender add-ons that can break the connection when you're going from one network to the other. And they'll also replace all the first gen with second gen free of charge because the second generation units actually do carrier aggregation and they use different parts of the different 5G networks that Telstra has broadcasting different frequencies, and they can use that more efficiently than the first gen unit. So it makes sense for them to upgrade you and give you these new units. They can actually sell more 5G home broadband modems in different areas because each of the 3 telcos has limited the availability of those systems so they don't flood their 5G network for everybody else. But they're always adding more people in different suburbs, and it's an alternative to satellite, an alternative to traditional NBN, and you get 300 to 600 megabits of download speed without having to worry about your garden being dug up if you get fibre right to the premises. So a really good set of announcements from Telstra today.
What about the existing NBN satellite network? Does that mean that's redundant, even though it's less than 10 years old?
No, NBN is still using it, still offering their Sky Must service, and they also have had to come to the party with unlimited downloads. They started with a trial in evening periods where they were sort of unlimiting things like Netflix and that sort of usage, which previously was causing problems because they only had a certain amount they could download over the system. Yeah. Elon Musk came in, completely revolutionized that. $130 a month gives you 100 plus megabit download, gives you good upload speeds, and so it's welcome competition. Competition's always welcome, and it's forced the NBN to think about their satellite plans too. But at the moment, I mean, they also have 5G spectrum. They're a telco competitor, even though they supply all the other telcos as a wholesale. I mean, they have to wholesale in theory what they're doing. So look, Telstra is just using the fact that it can get a whole range of other services from different players. But Telstra is working with different satellite providers, and they want to be able to use some of their backhaul with Elon Musk's Starlink, but also with the OneWeb to be able to mitigate when they have outages so that the entire state doesn't go down, and they can allocate resources and eventually also they want things like AI to fix network problems automatically, self-heal. And they were concerned about the problems of AI being poisoned and giving false information. I mean, they didn't mention it, but it's the old garbage in, garbage out. And in fact, we just had one of the US courts say that freedom of speech should be preserved and that some of the social networks shouldn't be censoring people. And I was thinking in Australia we need a First Amendment type of referendum in Australia where we can guarantee freedom of speech and not being censored by government ministries of truth or companies acting on behalf of the government. And we've got to fight battles in Australia with the censorship that is being talked about here with the misinformation and disinformation, which can effectively even police what people are saying in private WhatsApp and other messages.
Yes, but we'll have the government to tell us what's right and wrong now.
Well, but that's the thing, I mean, of course, that's the problem. So the issue is freedom of speech is something that we should replicate globally and it should be saved in the state.
What about Geoffrey Hinton's idea that there has to be some sort of a watermark put in anything that's created by AI so we know what it is? That
is a great idea. I mean, being able to tell what is AI-generated content. We need AIs to be neutral. If you want a left-wing or right-wing or other point of view, you should be able to ask your AI to tell you what that point of view is. But the information it presents to you should be neutral until you ask it for different views to be applied. I think that Hinton's warnings as the grandfather of AI should absolutely be heeded.
Well, Hinton says for every 99 people, very smart people, working to make AIs better, there's only one person working to make sure they're safe.
Well, obviously that ratio has to change. We need to be ensuring that our AI is explainable, ethical, trustworthy.
When Luke Skywalker said, "May the Force be with you," we didn't know he was talking about Skynet.
Well, I mean, that's the eternal battle of good and evil in that particular story. Hopefully there's more of us on the good side to fight back against the bad, and ultimately I hope we muddle through and win.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.